Hello class! Today we are dividing line segments on the coordinate plane again. This time we are going to divide them according to specific ratios. Instead of the last video where we just split it right down the middle looking for the midpoint, here we're going to split it in a ratio. Maybe we want to split it at a ratio of 2 to 1 or 3 to 7 or whatever it is, okay? So that's what we're going to look at today. So here's our question. What are the coordinates of point P that partitions the directed segment from point A at 2, 4 to point B at 6, -1? And we want to split it into a ratio of 5 to 3. All right. So what that means, we're going to take this segment here and we're going to put point P somewhere on there that splits the lengths at a ratio of 5 to 3. Now, very important question. Where do we want this to be closer to? Do we want it to be closer to the A or closer to the B? The question, so we have 5 to 3, so we're going to have one big piece and one little piece. Where do we want that big piece to be? All right. Well, it tells you this is a directed line segment. That means it goes in a specific direction. And that's going to be whichever order they are listed in. So point A is where we start. So we want 5 to be on the A side and 3 to be on the B side. So it's going to be bigger distance here, smaller distance here. So it's going to go somewhere closer to the B than it is to the A. All right. Question is, where? Okay. Now, if it's a ratio of 5 to 3, does that mean this one's going to be 5 units and this is 3 units? No. What that means is I'm going to divide this into, let's see, 5 plus 3 is 8. So I'm going to divide this into 8 different units, and I want 5 of them to be over here, and 3 of them to be over here. Basically what it means, but I don't want to actually figure that out. I don't want to use distance because it's going at an angle, so I'm not going to use distance and figure that out because that's going to be difficult too. What we're going to do is we're going to take this and separate it out. We're going to start by looking at the x's. Okay, so from A to B, what do the x's do? All right, so we're just going to look at this distance here. All right, so we're going to get us a new x, and we're going to start with the x's. All right, so let's see here. We're going from 2 to 6, so we saw distance earlier. We just subtract them, right? So 6 minus 2, x2 minus x1. 6 minus 2, that's going to give us our distance. Now, of that would be 4, right? So of this distance, how much of it do I want for the A side? Well, I want 5 to 3. So that means I want 5 out of how many? Well, 5 plus 3 is 8. So I want 5 out of 8. So I want 5/8 of this distance. Okay, so that tells me how far my x's are going to move from where? Where do I start at? Well, I start at A, right? Start at my beginning point. Start at 2. So I'm going to take this, and we'll just break this down here. So 4 times 5/8, which is 5 over 5 plus 3, plus 2. And you can just take this and stick this in a calculator. I have one here. Let's turn it on. Okay, my numbers are all messed up. There we go. Let's clear that out. So we have 4 times 5 over 8. Hit the parentheses, there we go. Plus 2. And we get, I think we were 4.5. All right, 4.5. So my x value for point P is going to be 4.5. So 2, 3, 4.5. So there's my x value. Now I got to figure out what is my y value. So we're going to go down from A to B. I still want a ratio of 5 to 3, right? So from A to B, I need to know, just like we did with the x's, I need to know how far is that. So again, we look at the distance on this, which y2 minus y1, so -2 minus 4, right? Sorry, not -2, -1 minus 4, y2 minus y1. What is the ratio of this? What fraction of this little green arrow do I want? Well, again, 5 to 3. So 5 over 5 plus 3, a total of 8. And then where do I want to move it from? Well, I want to move it from where I started at, right here, 4. Okay, so let's see, we just work that out. -1 minus 4 is -5, which makes sense. We're going down, right? So we have a negative move times 5/8, same ratio we had up there, plus 4, where I start. And we put that into the calculator. Put that in, where'd my calculator go? Okay, here it is. it's popping up. There we go. Okay, so we have -5 times 5/8 plus 4, and we get 0.875, or if you prefer it as a fraction, 7/8. There it is, 0.875. Here's my y. So my y, I'm going to come down here to 0. That's going to be just a little bit below the 1. There's my answer. Now this is great, this is lovely. What I want to do now, I want to take this process that we did, and let's put it into a formula. That way next time it's a little bit faster. All we have to do is plug it in, right? So the first thing we did x2 minus x1, right? Because we wanted the distance for our x's. Then we took the first number in our ratio over the entire thing, those two added up, plus wherever we started. So right there. You take your x's, you subtract your x's, x2 minus x1. Do not flip this around. Don't go x1 minus x2. It'll mess it up. You'll end up, instead of your line going this way, you'll end up with your line over here. And that's not what we want, right? Because then we'd have our answer over here, and it's not even on the segment. That's no good. So make sure you do x2 minus x1. Then the first number in your ratio divided by the entire stuff in the ratio. And that tells you how much of this arrow you want. And then plus your starting point. So make sure you start here and not at 0. All right, I want to start that. And then you do the same thing for your y's. Only change is y2 minus y1. This ratio is the same. Still 5:3, right? So it's be 5 out of 8 total pieces, plus your starting point. Okay, we're going to do one more example of this right here. No grid this time. So we want the coordinates of point P that partitions the directed segment from D to C into a ratio of 2:4. All right, so let's start with our formulas. All right, so now that we have the formulas, we can just use the formulas. So we want x2 minus x1, first number of the ratio divided by the two numbers added up, plus x1, and then we'll do the same thing for the y's. All right, so all we got to do is plug it in. Right there, just plug in all of the numbers. I got them nice and color-coded for you, makes it easy. Pull out our calculator here, and let's type this in. So we have 1 minus 9 times, let me do my fraction thing here, 2 over 2 plus 4, not the arrow out of the fraction, 2 plus 4 plus 9, and I get 19/3. Let's change this to a mixed number. Those are a little bit prettier than 19/3. 19/3 is fine. That's definitely an acceptable answer, but there we go. 6 1/3. Do not tell me that that is 6.3, because it's not. It's 6 1/3. All right? 6.3 is 6 3/10, not 6 1/3. Different thing. Okay. So there's the x value is at 6 1/3. So now we do the same thing for the y's. Take our y's, plug them in. Everywhere we had an x, we're going to put our y. y2 minus y1. Don't get those backwards. Why did I say c is y2? It comes second alphabetically. Why did I say c is y2 and d is y1? That's right, because it's listed second, right? D is listed first, so D comes first, because it's a directed line segment. So we're going to plug this into our equation. So we have 7 minus -15 times the same ratio we had over there, 2 over 2 plus 4, plus, where did we start? -15. So I'll get my calculator back up. Let's move that over so I can see what I'm typing. So we have 7 minus -15, close parentheses, times, pull up my fractions, 2 over 2 plus 4. I could just easily type that in as 6. I did it again. Let's not do that. There we go. Get outside of that. And then plus -15. And we get -22/3. That's, I mean, I could change that to a fraction if I wanted. Or, oh, sorry, I don't want a fraction. Decimal, there we go. negative 7.66666, repeating 6. It'll accept it if you put a repeating 6, but don't tell me that's negative 7.67. That changes to a fraction, so please do. All right. Leave it as a fraction if it's a fraction. And this is negative 7 2/3. Negative 7 2/3. Or you could leave it as 23/3. That's fine too. I'll take it that way. All right. So that's my x. There's my y. So my answer is point P at 6 1/3, negative 7 2/3. Right. Kind of complicated. The formula is a little ugly, I will admit. But it's not too bad if you take it step by step. First, how far am I moving? Okay, what fraction of that do I want? And where am I going to move it from? Okay, if you think about it like that, it makes a lot of sense, and it's not too bad. All right. Hopefully that helps, and I will see you in the next video.